So, gel electrophoresis is a method for separation and analysis of our macromolecules and their fragments, which is based on their size and charge. So, charged molecules move through a gel when an electric current is passed across it. An electric current is applied across the gel so that one end of the gel has a positive charge and the other end has a negative charge. The movement of charged molecules is called the migrations. Molecules migrate toward the opposite charge. In this home-based experiment, I'll be using food dyes of different colors and separate these dyes in a homemade gel electrophoresis. The tools I use for this home-based gel electrophoresis is alligator clips, pliers, measuring beaker, a tupperware to run the gel, two color of food dye or food coloring, green food coloring, and dark reddish yellow food coloring, agar powder, baking soda, a copper wire, and 5 times 9 volt battery. I first use the pliers to cut out the wire and obtain the copper wire inside. I then place some baking soda in a measuring beaker to be added in a pan. I first added water in the pan and added agar powder, then added the baking soda powder. I then mixed them up. After a while, during the bubbling water formation, I closed the stove. I made a comb with a stick, some clips and tapes, and a straw folded. I added the mixture in the tupperware containing the gel comb and let it to dry. Meanwhile, I assembled the 9 volt battery. The usage of 5 times 9 volt battery is equal to 40 volt, which when the gel electrophoresis is run in the lab, it is at 120 volt. But for this simple experiment, 40 volt is good enough. I then took out the comb slowly after it has been dried, and the well can be seen here. I then cut out the both end part of the gel to later place the copper wire. I then added the running buffer containing about 0.2% of baking soda mixed in the water. It covers the gel and transmits the charge through the protein gel, allowing electrophoresis to occur. The running buffer contains ions that conduct electric current through the gel. I placed the copper wire at both ends of the gel. Next up is the addition of food dyes. I added the green dye first, then I'll be adding the dark reddish yellow dye. The food dyes behave in a similar way to DNA molecules during electrophoresis, and any bands produced can be visualized directly in the gel. After that, I added a bit of mixture of both green dye and dark reddish yellow dye. The placing of food dye must be careful not to leak into other wells, but it's okay to be spreaded on the gel. I then connected the negative end of battery closest to the well and connected the positive end of battery farthest to the well. The bubble formation indicates the gel electrophoresis is running. In this time lapse, it can be observed that the food color dyes has been migrating to the positively charged side. Based on the experiment, the green food coloring at well number 1 traveled least furthest, meanwhile the dark reddish yellow food coloring traveled farthest. On the third well, the reason I added mixed colors of green and dark reddish yellow is because to show that this electrophoresis can separate molecules, in this case food coloring, at different weight. On the third well, it can be seen that the dark reddish yellow food coloring travels farther than on the green one. Electrophoresis separates the sample by size. Smaller samples or molecules can move faster and more easily through the gel, while larger samples or molecules move slower. It can be concluded that the green food coloring are larger sample and dark reddish yellow food coloring is smaller sample.